Dear students, welcome to the digital learning platform of Department of Collegiate Education. From this session, we shall start discussing the topic of logarithms, antilogarithms and their uses. So the learning objectives of this chapter are to enable students to get fundamental knowledge of logarithms, to enable students to understand laws of logarithm, their uses in everyday life, to enable students to solve tedious arithmetical calculations using logarithm technique. So, without wasting much of the time, let us begin with the topic of logarithms. Logarithms were introduced by John Napier in the year 1614. This technique was used by navigators and astronomers in the earlier days. This is a method or technique used to make difficult arithmetical calculations comparatively easy. In this technique, we convert numbers into log values using logarithm table, and in the end, we reconvert log values into numbers using antilog table. In other words, to put it in simple words, logarithm is nothing but an index or power written in a different form. For example, you might have heard 5 raised to 3. This equals 125. 5 raised to 3. This means that 5 number has to be multiplied by itself 2 times to get the result of 125. Dear students, this form is known as exponential form. In the logarithm form, 3 is called a logarithm of 125 to the base 5 and is written as log of 125 to the base 5 equals 3. So this is logarithm form. Similarly, 3 raised to 5 equals 243. This is exponential form of a number. Log of 243 to the base 3 equals 5. This is the log form. Similarly, 4 raised to 6, this equals 4096. This is exponential form. Log of 4096 to the base 4 equals 6. This is log form. Exponential form, log form. Now, having said that, theoretically, it is possible to calculate logarithm of any number to the base of any number, but in practice all logarithms are calculated to the base of 10. These are called common logarithms. Usually the base 10 is not written but it is understood. For example, 10 raised to 4, this equals 10,000. This is exponential form of a number. In log form, we write this as log of 10,000 to the base 10 equals 4. Log 4 means that the base 10 has to be multiplied by itself 3 times to get the result of 10,000. Here the base 10 is not written but it is understood. So log of 10,000 to the base 10 equals 4. This is written as log of 10,000 equals 4. Now moving forward, there are two parts of logarithm. First part is called characteristic. Characteristic is the integral part of a logarithm value and it may be positive or negative. The decimal part of a logarithm value is called mantissa and it would always be positive only. For example, log of 348 to the base 10, this equals 2.5416. Here the base 10 is not written. Here in the log value of 2.5416, 2 is the characteristic value. This is the integral part. Whereas 0.5416, this is decimal part of a log value and this is called as mantissa. Now having said that, now we learn how to convert numbers into log values. There are two parts of logarithm. First is characteristic and the other is mantissa. First, let us know how to find out characteristic. There are two rules to find out characteristic. Rule 1 is applicable when the number is more than 1 and rule 2 is applicable when the number is less than 1. So rule 1, when the number is more than 1, then characteristic is positive and it is 1 less than the number of digits in the integral part. Whereas rule 2 says or when the number is less than 1 or when number is a pure fraction, the characteristic is negative and it is 1 more than the number of zeros immediately after the decimal point. For example, here 3 numbers are given: 37.52, 4623.1, 6.21. Dear students, all these numbers are more than 1. So here in the 37.52 there are 2 digits in the integral part of that number. So 2 integral digits minus 1 would be the characteristic value. So 3, 7, there are 2 digits in the integral part, 2 minus 1 will be the characteristic value. Similarly, in the second example, 4623.1, there are 4 digits in the integral part. So 4 minus 1, 3 would be the characteristic value. Similarly, in case of 6.21, there is only 1 digit in the integral part. So 1 minus 1, 0 would be the characteristic value. So by applying rule 1, we found out that the characteristics are 1, 3 and 0. Similarly, when the number is less than 1, so when the number is less than 1, then we have to see number of zeros immediately after the decimal point. Here 3 examples are given: 0.80, 0.07, 0.000670. So in the example of 0.80, right after the decimal point there are no zeros. 0 zeros plus 1, that is characteristic would be 1 and it is negative. So characteristic is minus 1. In the example of 0.07, after the decimal point there is 1 0. Right after the decimal point there is 1 0. So 1 0 plus 1, characteristic would be 2 and it is negative. So characteristic is minus 2. Similarly, in the third example, 0.000670, right after the decimal point there are 3 zeros. 3 zeros plus 1, characteristic is 4 and it is negative. So characteristic is minus 4. Dear students, as I already said, there are 2 parts in a logarithm value. The integral part is called characteristic and the decimal part is called mantissa. The characteristic part is found out by mere observation, whereas mantissa has to be ascertained from the logarithm tables. So to ascertain from the logarithm tables, the mantissa is to be found out considering the first 4 significant digits in the order in which they occur irrespective of the position of the decimal point. For example, if the number is 42.37, this number has to be considered as 4237. Similarly, for the number 0.02348, the 4 significant digits, the first 4 significant digits 2348 are to be considered for finding out mantissa. Now reading mantissa from the logarithm tables. The first digit, the first 2 figures or first 2 digits are to be located from the first column of the logarithm table. The third figure or third digit is found out in the next columns headed by numbers 0 to 9, and lastly the fourth figure or the fourth digit is to be located from the mean difference column headed by 1 to 9 columns. For example, to find the log value for 4567. Okay, here the four digits are 4567. First four significant digits are 4567. The first two digits 45, they have to be located in the first column. The third digit is located in the next columns headed by 0 to 9 columns. So sixth column. Here the value is log n is 0.6590. So to the value found out by locating first three digits to this value, the value for the fourth digit, which is mean difference value. So the value for the fourth digit, this has to be added to the value found out from three digits. So log value for 456 is 0.6590. To this add mean difference for 7, which is also 7. So if you add this together, the log value for 4567 would be 0.6597. So now the final log value will be, in case of 4567, here there are four integral digits. So the characteristic value will be 4 minus 1, 3, and the multiplier value is 0.6597. So the log value for 4567 is 3.6597. Similarly for number 456.7, here in the integral part there are three digits. So 3 minus 1, 2 will be the characteristic value, and the log value and the multiplier value will not change. Okay, because four figures have to be considered irrespective of the decimal point. So the multiplier would still remain 0.6597. So the log value for 456.7 is 2.6597. Similarly for 45.67, log value would be 1.6597. 4.567, the log value is 0.6597. For log value for 0.4567 is, here the number is less than 1. So that means after the decimal point, we have to see number of zeros immediately after the decimal point. Here in the number 0.4567 there are no zeros. So 0 zeros plus 1. So the characteristic will be minus 1. And multiplier value will not change, 0.6597. So 0.4567 log value will be minus 1.6597. Similarly for number 0.04567, here after the decimal point there is only 1 0. So 1 0 plus 1, the characteristic will be 2, and it is negative, minus 2.6597. Similarly for 0.004567, here after the decimal point there are two zeros right after the decimal point. So 2 plus 1, 3 would be the characteristic value. So 3 will be the characteristic value. So minus 3.6597. Now lastly we learn how to find antilogarithm value or the number corresponding to the log value. Antilogarithm means it is a reverse process. It means number corresponding to a given logarithm. Till now we studied how to convert numbers into log values. Now we learn how to reconvert log values into numbers. To find antilogarithm, The rule says ignore characteristic for the time being and use mantissa only to find antilogarithm from the table in exactly the same way as in the case of finding the logarithm. So antilog value has to be found out from the antilogarithm table. Using mantissa, you have to find out the value. Now characteristic will now show the position of the decimal point in the result. If the characteristic is positive, then the number of digits in the integral part will be one more than the numerical value of characteristic. If the characteristic is negative, then number of zeros after the decimal point will be one less than the numerical value of characteristic. Let us take an example. Now we have to find out antilog value for, let us say, 3.8609. So ignore characteristic for the time being and focus on mantissa only. So the mantissa is 0.8609. So 0.86, locate first two digits in the first column of the antilog table. So 0.86. So in that corresponding row 0.86, locate third digit, the value headed by the column 0. So the value is 7244. So this is the antilog value for 3 figures. To this value add mean difference for the fourth digit. The fourth digit is 9. So in the 0.86th row, the mean difference value for the column headed by 9 is 15. So add this 15 to the value arrived at using 3 digits. So 0.860, the value is 7244. To this add mean difference for 9, 15. So the final result will be 7259. So for all these numbers, the antilog value from the antilog table will remain the same, which is 7259. Now the characteristic will decide where we have to put the integral point. When the characteristic is positive, then number of digits in the integral part of that number will be one more than the numerical value of characteristic. That means in the first number 3.8609, the characteristic is positive 3. So to this 3 add plus 1. You add 1. So number of digits in the integral part will be 4. And the final number will be 7259.00. Similarly, in the second example, 2.8609, here the numerical value is 2 and it is positive. To this 2 add 1. So number of integral digits will be 3 and the final result will be 725.9. In the third example, 1.8609, here also the characteristic is positive. To this add plus 1. So number of integral digits will be 2 and the final number will be 72.59. Similarly for 0.8609, the number will be 7.259. In case of characteristic negative, when the characteristic is negative, then the final result will be a pure fraction. When the characteristic is negative, then the result will be a pure fraction. Now the characteristic value will decide how many zeros need to be put right after the decimal point. So when the characteristic is negative, then number of zeros after the decimal point will be 1 less than the numerical value of characteristic. That means in case of log value minus 1.8609, here the characteristic is negative and it is minus 1. So 1 minus 1 from this 1 characteristic value we need to deduct 1. So 1 minus 1 0. So this means right after the decimal point we need to have 0 zeros. So no zeros. So minus 1.8609, the number will be 0.7259. Similarly for minus 2.8609, here the characteristic is minus 2. From this 2 you deduct 1 value, 1, deduct 1. So 1 remains. So 1 0 need to be put after the decimal point. That means the final result will be 0.07259. Similarly, in case of minus 3.8609, from this negative characteristic of 3, deduct 1, that means 2. So right after the decimal point, 2 zeros need to be put in the result. That means then the corresponding number for the logarithm minus 3.8609 is 0.007259. So these are the references I have used for making this presentation. Thank you, one and all.